Data Futures Bays West is a precinct to prepare us for the future, now. It builds upon the rich heritage of Bays West to establish a high-tech research precinct in which the data center plays a pivotal role as an urban catalyst to ensure this phase of transformation equips us to face our challenges now and into the future. The design of the data center focused on 5 key principles to guide its development as an urban catalyst. Firstly, the data center must integrate and empower research across the master plan to achieve the identified sustainable development goals. Secondly, Data Futures will revitalize the heritage of Bays West through sustainable adaptive reuse of the grain silos and embed designing with country frameworks. To achieve this, a modular building strategy has been developed with a key focus on circular building principles, as well as the design for manufacture, assembly, and disassembly. As a research precinct, the data center will be at the forefront of technology, utilizing immersive cooling and co-robotic maintenance to increase efficiency and minimize downtime. Finally, the waste heat produced from the data center will be reused throughout the agri-tech precinct for the research and development of future food practices. These practices will engage with the public to foster the next generation of researchers and scientists. Data Futures Bays West responds to the urgency of action outlined through the United Nations Sustainable Development Goals identified during our master planning phase. Our aim of providing access to affordable, sustainable, and modern energy, conservation of oceans, seas, and marine resources through sustainable management of water, and sustainable consumption and production patterns is achieved through the energy, water, and agri-tech research precincts. These precincts are enabled by building resilient data center infrastructures which enable research and innovation. Bays West could be considered a highly disturbed site, given the waves of change which have occurred here, from its natural environment to early settlement and extreme change due to land reclamation. Despite this, the saltwater country, Gari Gurad, and freshwater country, Natai Gurad, have endured these changes. These place stories and themes identified are a first step in identifying how we reimagine a space where this spirit can live on. The original silo's footprint provides an opportunity to embed place stories within the site with a designing with country framework. A key focus of this area is to create regenerative public spaces that utilize cultural stories and native ecologies that perform as a civic, public, and ceremonial space. The reinterpretation of the historical silos through sculptural intervention to create learning circles acts as an urban catalyst to recognize that this country holds important stories and knowledge that describes thousands of years of heritage and culture from multiple different perspectives. Learning country through story is a process that will expand in depth and complexity over time and cannot be achieved in a short time span. These meeting and ceremonial places establish a space to be used by all and a long-term framework which celebrates all layers of history, knowledge, and culture of this place. It is often said that the greenest building is the one already built. Research has increasingly supported this statement, finding that adaptive reuse of existing buildings can result in fewer adverse environmental impacts than sustainable new construction. We have seen the adaptive reuse of the Glebe Island silos throughout its history, from first being a vessel for grain storage to cement and sugar storage in the 1990s. Throughout the next phase of the silo's transformation as a data center, a modular building strategy will be incorporated as a key framework which enables an efficient and flexible data center layout. This also provides a framework for a diverse range of future uses after its life as a data center. The building utilizes a modular design strategy which incorporates circular construction principles and is designed for manufacture, assembly, and disassembly. The family of modules consists of the primary data center, office, vertical farming, and germination modules, as well as service modules consisting of vertical transport, electrical distribution, network distribution, backup generators, and cooling. The modules have been formulated as a kit of parts, which can be prefabricated off-site. Given the proximity to the harbor, the sizable modules can be transported via water, reducing logistics complexity and emissions. The modules can then be lifted with a crane that is fitted with a bespoke spreader bar and lowered into the silos during construction in the required configuration. The building planning strategy is divided into 4 primary data center bays with 3 intermediate amenity and vertical transportation zones. The lowest floor plate band begins with the immersive cooling supply system. Next are the data center levels and then the heat reuse and agri-tech modules. The servicing silos are comprised with electrical and network distribution, as well as backup generators. Vertical transportation is spread evenly across the building. The servicing modules are placed with operations and maintenance considerations should major equipment failures occur. Equipment requiring replacement can utilize the 4x4 meter lifts positioned within the 3 vertical transportation cores. The data center utilizes an immersive cooling strategy to reduce the overall footprint of equipment required as compared to a traditional data center arrangement. A traditional server arrangement would require 6,000 5-kilowatt racks to achieve a 30 megawatt data center. With the high-density arrangement possible with immersive cooling, this would be reduced to 300 immersive cooling modules. The immersion cooling data server is positioned on a raised access floor within the data center module. The structural components of the module comprise of glulam beams and columns with a 5-layer cross-laminated timber floor panel. The module dimensions are offset from the existing concrete silo walls to create a largely independent structural solution whilst also providing tolerance during installation. Modules are tied to the concrete silo walls to provide lateral restraint through steel plate fixings. For maintenance, co-robotics is implemented within the data center and vertical farm to improve efficiency and reduce overall downtime. The data center is serviced by 2 primary service risers. The left-hand side riser is responsible for reticulating the immersion cooling liquid, whilst the service module on the right-hand side provides power and network connectivity. The power and network strategy utilizes high-level suspended cable trays to provide easily accessible and legible electrical and network reticulation. The cooling strategy utilizes an electrically non-conductive liquid for the immersive cooling of data center equipment. This is pumped through the building, bringing the liquid heated by the data center servers to the germination module. Here, the heat is reused to maintain a constant temperature of around 30 degrees to promote the success of seed germination. The heat is then rejected through the use of a cooling fan, which can also control the temperature of the farming module above. The cooled liquid is then returned to the initial tank for the process to repeat. The food research modules are formed in response to the global food system's significant environmental footprint. Agriculture occupies nearly 40% of the Earth's surface, and irrigation of these crops accounts for up to 70% of global water usage and contributes to around 11% of global greenhouse gas emissions through its production, distribution, and processing. With its rising demand, urbanization of food and agriculture in our cities not only seeks to lessen the distance traveled, but also promotes transparency to educate the public to form a sustainable food community. Fundamental to the urban catalyst strategy, public engagement plays a key role to evoke awareness and change. This is not only achieved through the historic and cultural layers, but also by showcasing the latest advancements in technology. The Agri-Tech Precinct is expanded as a showcase for public engagement through the adaptive reuse of the existing gypsum storage facility as a market hall where users will be able to learn about, participate in, and taste the latest produce farmed on the site. This engagement is achieved in both day and night economies, activating data futures as a key destination of Bays West. Today, we have explored how these 5 key principles have shaped the urban catalyst that is Data Futures Bays West. Bays West will represent a new kind of Sydney urbanism that respects and celebrates country. It will build on its natural, cultural, maritime, and industrial stories to shape an innovative and sustainable new place for living, recreation, and working. New activities, places, connections, and destinations will enrich Bays West's character and meaning over time through its data-empowered research precincts and public spaces that embrace its natural and cultural heritage.